Good morning. Today on DIY Solar Power with Papa. Today we're going to be talking about how we installed the soft start on this 127,000 BTU pool heat pump. It's 240 volts. This thing's got a 7.5 horsepower compressor. This thing is a monster in there. And when this thing, I don't know if you can see that in there or not. Go over here. If you can see how tall that is, it's kind of hard to tell, but the thing is almost half the height of this, and this thing comes up almost to my chest. So it's a pretty big compressor. I don't know if you can see on this one, but that's a really smaller, I mean, it's tall, but it's not, it's half the width of that other compressor. That's a 3.5 ton. On this 4 ton, it's a little bit, I think it's a little bit beefier, but still about half of the width of that, thickness of that. But the bigger difference is I put a soft start on this 3.5 ton right here, heat pump for the house, for their air conditioning. And that inrush on that was 72 to 79 amps on each one of the 120 volt legs. When we put that soft start, it dropped it down from around 24 to 18 amps. And after starting it up, stopping it, starting it up, stopping it 5 or 6 times, it finally settled in around 18 to 20 amps on each of the 120 volt legs. So much, almost a quarter of the inrush amps on each one of those legs compared to before installing that soft start. Now on this one, I have not put one on, but the inrush amps on this, because it's a 4 ton versus a 3.5 ton, this is going to be about 109 to 119 inrush amps when I go to start this without a soft start. When I install it on there, I'm thinking I'm going to be in the mid 20s, mid to upper 20s, maybe the mid 20s after I've run it 5 or 6 times. You got to start it up and stop that soft start 5 or 6 times after installing it to kind of get it dialed into your compressor. So it kind of learns about your compressor as you start it and stop it. So now in this thing, before I installed the soft start on this, the inrush on this was about 144 to 166 amps on each of the 120 volt legs. And that was way too much to start it up on the 12 kilowatt low frequency off-grid inverter that we have. So once I installed the soft start on this, it's dropped it down to about 40 to 52 amps on this. When I dialed it in, and after starting it like 5 or 6 times, it finally got it down around 40 to 43 amps on each leg, compared to 144 to 166 amps on each leg. That's a huge difference. That's like almost a quarter of those inrush amps. And then it settles. I know this starts settling in around 23 amps running current on this on each leg. So that's around 46, 48 amps between the 2 legs of running current that I need. And I actually have a 50 amp breaker on this pool pump for the utility grid power. And I also put a 50 amp in. I put some new breaker boxes in the garage, and I'm running all these air conditioners and the heat pumps through those right now. So when we went to go install the soft start, we installed it right there. You can see the soft start is right here. First thing we had to do is turn our utility power off. And then we pulled our fuse plug out of this AC disconnect, and here's our fuse plug. So there's no plug in there at all. And so we have no power in there because the grid is turned off. So we turn that power off. We checked it with a meter, make sure there's no power coming into this. And the first thing we did was we realized that we just didn't have the room in here to install that. So we installed it in here, and there was already a grommet here for us to run the wires through. So on this, you can see that this ground wire and the red and black wire here coming from my utility grid. Well, actually, it's not the utility grid. It's just running over into the AC disconnect for the utility grid. That is my wires running into this. So you got 120 volts on this leg on the black, 120 volts on this leg, and then you're grounded on the green here. So the first thing I had to do when I did this was I connected this pink wire right here was connected right here to this red on the top of this relay. So we had to take it off, and we had to run that pink wire. Oops. That pink wire here actually is fed to this. You can see the wires moving. That pink wire right there, that goes to the compressor. So that wire that goes to the compressor goes right in here. And in order to replace the wire, this pink wire that came off of here, we installed this red wire right here on the soft start. So the first one is the run winding. We took the wire off the compressor for the power and ran it into the soft start. And then on the active T2, we ran the red wire that was supplied with a soft start through this grommet over here, and then connected it where that pink wire used to be. Now, the next wire we did is this reddish violet wire I'm holding right here. That is the run capacitor. And that run capacitor goes up here to our C for our compressor on this capacitor right here. Now make sure before you start working on any of this that you short out the capacitor with a screwdriver, making sure you're only touching the insulated plastic handle and not touching any metal with any part of your body. And you need to short out the 3 contacts up there. There's a Herm, the capacitor, and the fan on the top of those. There's 3 different contacts coming out of there. Short them all together to discharge the voltage in there. And so we've got those 3 wires coming out of there. We've connected the run winding, the run capacitor, and the active T2. Now the next wire we connected was the black common, which is right here, this black. And we connected it right here to this black terminal in the middle slot here on this relay. So if you can see that right there, that wire was supplied along with this violet wire. The red, the violet, the black, and the blue were all supplied. So the next one and the last wire coming off of this is the start winding, and that's the blue wire down here. These are both connected to that green contact relay right there. And they're on each end. That middle part right there is not used. Those are the blues on one end, the blacks on the other. So the black on that start winding goes to the black over here. The blue goes up to the Herm. Now, the one thing that did not come with this was we needed to create this wire right here, this brown wire. And you'll see there's a yellow terminal contact right down here we had to use with a crimper, and the same thing up here, the yellow end on there. So we had to create this wire and make it. We had to run that from the compressor all the way up to the C for the compressor on this capacitor. Now, the other thing was this pink wire, which is connected down here to the bottom of this black wire, contact behind that, we had to disconnect that in order to run this with this soft start in here. If we weren't running the soft start, this wire was connected to the C for the compressor on this capacitor. So pretty easy to do. Took about a half hour. I actually had to stop and run to Home Depot to get those yellow connectors on the end to crimp on. But we got that connected together. And right now we temporarily have this double pole, double throw switch hooked up because we were going back and forth between the utility grid right there on that AC disconnect, which is the wires with these white on them. And then this is our solar coming off that 12 kilowatt. So when we have this turned over on this side, it's engaged. You can see right now, even with that thing not running, it's 0.6 amps that it's doing. So we're going to start this thing up. Remember I said when we used to start this up before we installed that soft start, about 144 to 166 amps. So we'll go ahead and start that up. There we go. Started that up. Started right up. And if we look over here, that was 49.9 amps on that one leg right here. So it was probably 49.9 on the other leg as well. So about 50 amps on each one to start up from being 144 to 166 amps. That's quite a big difference. That's almost a 75% drop. Now, if we turn this off, we can see that right now we're running right around 23 amps on this leg of this. So we've got that running and the pool's heating up. And that gives me about 10 to 15 degrees depending on the temperature outside, from the temperature of the pool water coming in to the temperature of the pool water going out. It'll be anywhere from 10 to 15 degrees. Now here's that 12 kilowatt that we have using to run this right now. We just wired this up to this breaker panel over here. This is the 12 kilowatt. This is the 6 kilowatt breaker panel. So right now we have that wired in, and we're going to have to move our panels around, because what we're actually doing is we're actually using this right now as a utility grid to run when this drops below 51 volts. This, you can see it kicks in. So it's at 240 volts right now, but the battery will drop down. There we go. It's down to 49. And over here, you can see on this one, it's dropping it down when that utility kicks on. It's 49 volts over here, 48.9. Over here, we'll get over to the volts. Because right now, right now we're only bringing in 29 amps, but we're using, keep switching so quick that I'm trying to find the amps. 72 amps out of our battery. And so right there, it's not using, wasn't using anything of our battery amps. Now we're using 70, 73, 70 amps. Now it drops down to where it's just using the solar, and it's only, right now it's 10:30 in the morning, and it's not producing a lot of solar because the sun, it's the middle of November, and here's the south straight ahead. And if you look, the sun is right up there. It's pretty low in the sky. December 25th is the lowest point it'll get. So we got a little, like 6 weeks to go. And then the sun will start going back up higher in the sky and we'll get more sun. What we did was we kind of used the panels off of this to support this. And we're just using this as utility grid right now. So as the sun gets closer to around 11 o'clock, we'll be able to keep this thing running with no problem. But right now, you can see on the utility grid, the line going across shows that it's charging the battery and bypassing. Right now, it's turned off. There's no line. And there you go. The line kicked up. Now, this goes up to 54. When it hits 54 volts on charging the battery, it'll turn off. There it goes. It turned off. And as it drops down and this charges up, this voltage will drop over here as it's charging this over here. When it gets to 51 volts, it's supposed to switch over to the grid power. So it should be switching over. It's taking a little while because it's only at 46.9. So it's kind of trying to level out there. See, we only have 29 amps coming in right now, and we're using 75 amps, 79 amps out of our battery. So as we move our panels around, we'll be able to get this up to about 70, 80 amps, and we'll only need maybe 15, 20 amps over here off of this. So we had to I just temporarily wired this up about 25 minutes ago. Right here's the wire. So you can see that for going into that breaker box over there, we got the red, the green, and the black. That's our output. This is our solar. We have two separate charge controllers. So we have that solar going down here connecting to that. And right here's our input. So we have our ground and we have our white and black. So we have hot 1 and hot 2. Each one of these are 120 volts. Same thing over here. Red's 120, black's 120. So we have that feeding in over here to this breaker box. We got a great deal on this. This is a 200 amp service. And with it, we got one of the double 30s and we got 3 20s. I got one of them, moved them over here. So I got 1, 2, 3, 4. So I bought 2 of these boxes for 42 bucks. It was normally 250 bucks. They had them on clearance. So they were last year's. So we were able to get a really good deal on that. Then we went and bought some extra breakers. Now, here's that 50 amp breaker that we had to install in order to run that heat pump out there. And you can see the wires running there. They go through there, they go down here, and they go through the wall and around the house. And once again, there's our our 6 kilowatt breaker box. And that was a great deal because I went and bought these 15 amp breakers, and God, those were 16 bucks a piece. And these were like 30 some bucks a piece for these 50 amps. And I think I bought another 30 amp and that was like 30 bucks. So that was a good deal to get 3 20s and 1 30 in there with that. So we also ran conduit, flexible conduit all throughout here, except for this input coming over here that I just installed. So it's working out really good. Just need to move those panels around so I can get more solar on them. All my panels are sitting basically straight up. So it's I need to get them facing more towards the south, but I really don't have a south exposure to speak of. Here's the south, and I've got very little room on this side at all. I do have 14 panels up here on these two pergolas on the top of them, and those are getting sun in the morning. So we're going to go ahead and turn this off for right now so I can talk. And the one thing that I wanted to give you a little heads up on is when you're working on this thing, and I was doing it over a couple of days, and I had this off for a couple of days, I wasn't feeling well. The capacitor drained on the voltage in it. So when I went to go start it up again, I put it on the utility grid, and I had that on there for about a half hour, and that charged that capacitor back up. It charges it up pretty quick. I didn't need to leave it on that long. But I noticed that when I tried to start it, there was nothing in the capacitor, so I had to take it off the solar and put it on the utility in order to get that going. And once I did that, and the only challenge, like I said, I had was I had to create that brown wire to connect from the compressor input voltage to the capacitor, and I had to disconnect the one from the bottom coming in, the input coming in. I had to disconnect that from the capacitor. They won't run at the same time. If you have it on the utility, for some reason it will, but when you put it on solar, you need to disconnect that one because it's already got on the other side, on the top side of that, I'm connecting that. So, but I was really surprised that that actually started that thing. I thought that was way over the amount of amps for that soft start, but I'll show you that soft start. I bought that. It was $249 for both of them that I bought, and that's including tax and shipping. That got it from, I just Googled hyper engineering soft start, and it came up on the web search, and it actually, here it is. It comes from Illinois, and when I got it, it was shipped in the mail. It takes about 4 to 6 days to get here. And the one that I got was right here. It's the SS1B16-32SN. That's for 32 volts and 16 to 32 basically running amps is what you'll need that. It'll go up. I don't know if it has it on here. On the, here it is. So on your start, I'll try and get that to focus in there. On that, here's your single phase load, the load running amps down here, and your inrush amps up here. This says it'll go to about 130 something, but actually on their website, it actually showed it would go up to like 186. That was the reason why I got this. So it worked out really good. Here's your specifications over here on this box. Is 50 to 60 hertz, 32 amps, running amps. The rating is 207 volts. Duty cycle is 15 to 20 starts per hour, and gives you the dimensions. It's I don't know, there's the actual barcode and everything for that, but it's what it looks like. You know, you got your green here, you use one end, and the other end, the middle contact, you don't use at all, and then you use all three of these contacts right here. So, and they show you that over here on the end. That's what it looks like. So you use all three of those contacts, and only the end ones on this green one, there's 3 contacts that you can screw a wire in there, and you only use the 2 ends. But they give you the instructions with this. They're somewhat helpful, but you know, I watched a couple of videos. They give you a wiring schematic here. of this, and they have a conventional schematic of what your heat pump or HVAC would be for your wiring, and then they give you what the soft start wiring is. And like me, I really had to look at this part right here where it says identify the cable connecting the capacitor and the run cap. Remove that connection to the run cap. And then that's where I had to create the brown wire. I took that wire off and connected the brown wire from the relay for the power coming in on the compressor up to the compressor on the capacitor. So that was kind of a sticky point right there that I had to look at that. But these instructions are pretty good. Once again, we've also on the 12 kilowatt and the 6 kilowatt, we ended up bonding this in the grounding. So we have our grounding over here, but right here where we bring in our ground, there's a green screw right here that it was sticking out like this much. And you have to screw that thing all the way in. That it's screwed all the way in tight. When you screw that in, that goes through this breaker box into the steel on there, and it grounds the whole breaker box, and it grounds these ground wires. And it not only attaches for your bus bar here, your bus bar there, but it basically, when you screw this bus bar in, it connects it to your bonding right there. So I did that on both of those. So I do have these grounded and bonded to the breaker box and to the units, to each of these units. I don't have them grounded to the actual physical ground. They are actually grounded on these units and on those breaker panels. So we also did an upgrade since our last video. We had these Marine Auto breakers right here. They're just, this one's 100 amp. And when it trips, it breaks like that. After a minute or two, you'll hear a pop and you can reset it. You can use those like 10 or 15 times that they break, and then they're pretty much shot. So you got to replace them. So we decided to go to these new DC breakers. And this one over here is a DC only, and it's 63 amps. So we used two aught thin wire there to run the battery connection into that breaker down to our bus bar. And then this is like flexible. We got this at Harbor Freight. It's a 6 foot, I believe, flexible welding wire. So we did the same thing over here. We used 2-aught cable going into this breaker. It's 125 amp, and that's also 125 amp breakers. Ran them 2-aught down to the bus bars, and then the cables going to our battery banks. So we improved that. And we also use this flexible conduit to secure wires in there so you can't get a short out from one breaker to the other breaker. So pretty much it. We're having fun doing this. We're going to have to move some of our panels off of the pergola against the house because there's no sun on those anymore during the day. And we'll be moving those to where they're trying to face a southern exposure, whether it be on the wall or what. But we'll be moving those around, and we'll be able to run that pool heater. And we have to can't run that pool heater and keep your pool hot unless you have a thermal pool cover. So we'll be purchasing a new one. Ours kind of degrades when you roll it out. They're only good for like a year or two out here and they're shot. I don't care if they give you a 5-year warranty. They don't honor them. So My suggestion is get the 8 mil instead of the 12 or 16 mil, because it's going to last just as long, and it's going to be 40% to 50% less. So anyways, that's our video for today on connecting the heat pump to this 12 kilowatt off-grid Growatt inverter, low frequency. And I hope you have a truly wonderful and extremely blessed day. And please like, share, subscribe, and hit that notification bell. And we'll see you again. We'll be doing some other videos. Talk to you soon.